Hello and welcome, and thank you for joining us. You're listening to GPF Lewis Construction Methodology Overview for the new Energy Centre at Bath Lane, Bristol. My name's Malcolm Wright, and I'm the Senior Planner for the project.
And I'm Morgan Hambling, the Digital Engineering Manager. Together, we'll guide you through our proposed construction sequence, from day one logistics and enabling works, all the way through to structure, envelope and final completion.
This video aims to walk you through our approach at high level, with the key stages explained in sequence.
And for the full detail, including methodology, controls and timings, that can be found within our construction methodology statement and construction programme.
Logistics. From day one, our focus is on a safe, controlled delivery of the project, and that starts with robust site logistics.
Our logistics strategy is carefully planned to protect progress and minimise risk. This includes structured delivery booking, segregated pedestrian and plant routes, and a clearly defined loading and storage laydown area space.
All vehicles will enter the site and use a designated turning circle to safely navigate the site.
And all vehicle movements will be managed by a trained banksman, ensuring safe control of reversing and manoeuvring operations.
Once site establishment is complete, we begin the enabling works and initial site clearance activity.
This includes removing any obstructions, verifying ground conditions and completing all necessary pre-start checks.
Where required, baseline monitoring is implemented early, particularly where we're working close to third-party boundaries or sensitive assets.
That early confirmation supports safe delivery and reduces unknowns before progressing into below-ground works.
Works then progress to break out the existing hardstanding and begin ground reduction.
This is completed in a controlled sequence to maintain safe access routes throughout the works.
The ground is then prepared for piling, including formation levels, temporary access, and preparation for heavy plant and piling operation.
To support piling work safely, we form the piling mat using a reinforced build-up designed to distribute rig loading appropriately.
This provides a stable, compliant working platform for the upcoming piling activity.
And where required, a temporary berm is installed to support safe ground stability and access during excavation and piling operations.
Piling activities then commence, initially starting with the capping beam piles.
These piles are installed using a hit and miss approach, with the rig returning afterwards to complete the remaining piles.
All piles are carried out within controlled exclusion zones with strict monitoring of plant movements and working areas.
This keeps the site safe, maintains clear access and supports an efficient progression throughout the foundation phase.
Once the capping beam piles are installed to the contig ones, we progress to constructing the high-level CFA piles.
These are then integrated into the required thermal base build-up, ensuring the foundation design meets performance and interface requirements.
At this stage, we pour the concrete capping beam to tie the piles together and form the next structural element.
Once the piles are in place, we'll carry out pile cropping to achieve the required cut-off level.
For the thermal base piles, excavation and cropping works continue to reduce both the piles and surrounding grounds to the correct formation level.
This ensures everything is set to the correct level for the upcoming substructure and slab sequence.
We then construct and pour the pile caps and foundation bases. These elements form the key load-bearing foundation system for the Energy Centre superstructure.
Reinforcements and hold points are inspected prior to pouring, ensuring quality is captured early and reducing rework risk.
Before the main slab pour, we install the underslab drainage and service ducting.
This includes careful coordination of falls, routes, penetrations and interfaces, ensuring future connections can be completed smoothly.
This stage is tightly controlled because drainage and ducting must be fully confirmed before the slab is poured.
And getting it right here protects programme certainty and avoids disruption later on.
With ground preparation complete, the ground floor slab is formed and poured.
Blinding, damp proofing, installation and reinforcement are all installed as required to achieve the correct specification and performance.
Completion of the ground floor slab is a key milestone, providing a stable working platform for the superstructure.
And it unlocks the vertical build sequence, allowing for the structure to rise in a consistent and repeatable cycle.
To support the rising structure, a luffing jib tower crane is installed in a controlled, pre-planned operation.
This includes a fully engineered base arrangement, assembly sequencing and lifting activities delivered under strict exclusion controls.
We've looked to utilise the existing thermal storage base slab in order to prevent with doubling up for slab activity. Once installed, crane operations become the primary lifting solution for the frame, steelwork and envelope activity. We will look to use a telehandler, where possible, to lift cladding materials up onto the designated loading decks, as designated within our logistics methodology. This, we hope, will reduce hook time on the luff and jib crane and help promote efficiency. Tower crane operations are managed under a refined lifting strategy, including designated lift routes and restricted zones.
Lift and no lift areas are clearly controlled to protect people, property and adjacent interfaces.
All lifting is coordinated through daily planning, competent supervision and a strict permit-based approach,
which ensures safe operations, consistent control and minimal disruption to surrounding work areas. Works progress level by level through a repeatable cycle, including vertical elements, core walls, formwork, reinforcement and slab pours.
This structured sequencing supports predictable progress, quality control and safe access as the building rises. As a concrete frame reaches the upper levels, scaffolding is erected to provide safe access and edge protection.
This enables roof steel erection activities to proceed safely, with controlled working platforms and inspection regimes in place.
Steel stair install follows a structured sequence.
First, the steel columns are installed, followed by landings and then the stair risers.
This approach supports safe installation, access continuity and progression of internal works in parallel. With the structural frame in place, the external envelope sequence begins.
SFS framing is installed directly to the concrete frame, providing the support structure for cladding panels and associated interfaces.
This is a key stage in achieving enclosure and moving the building towards weather tightness,
which reduces weather risk and unlocks follow-on internal activities sooner.
To improve efficiency and reduce handling, cladding panels are loaded out onto the concrete frame floors in a controlled sequence.
This supports safe installation, reduces crane downtime and keeps facade progress moving consistently.
The installation will then move up the building, elevation by elevation, following a planned zone sequence.
Interfaces such as flashings, cappings and perimeter ceilings are completed in line with the facade system requirements.
External works are delivered in parallel where possible, with careful sequencing to protect completed areas.
This includes final drainage connections, service interfaces, access routes and reinstatement works.
As construction nears completion, external works, snag and inspection process will progress in a coordinated programme,
leading to a safe, compliant handover and achieving practical completion efficiently. Thank you for listening.